Hi, this is Tom Reardon, math teacher from Ohio. This video is one of several videos showing how to use the TI-Nspire dynamic geometry application to help students understand and discover geometric properties by investigation and exploration. Please press pause as needed. The bit.ly website shown here shows you where you can get more information, including several activities with student sheets and teacher notes. I included this photograph because I thought it really showed or illustrated what we're talking about with reflections. This is the Taff School in Connecticut. And a friend of mine, Kelly Kutach, who now lives in Bend, Oregon, sent me this photo she took just this past week because it fit in very well with reflections. All right, so let's go ahead and get down to it. We're talking about transformational geometry and especially reflections. So I have a triangle here, triangle ABC, that I would like to reflect about this line. And so this icon here does the reflection, so I'll click on that, and you can see that there is a reflection there. I can grab any point, any of the vertices on the pre-image and move it, and you can see that the image behaves in the opposite way. I can grab any of the vertices. I can grab the entire figure if I want. Okay, just kind of investigate, play, investigate, explore, discover. I can go ahead and reflect about a vertical line and do the same thing. Or I can go about a slanted line. And even though we want students to use technology to do this, we want them to also be able to do this by hand. So we have several templates that we've pre-created to help students with that. This one's called Connected Segments. I'm clicking on the Toolbox over here to get that. First, it doesn't look like any different, but when I now reflect about the horizontal line, you can now see we have lines that connect, or segments connect, the corresponding vertices. So again, I'll pull point C up here, and you can, I want them to discover what's true about these three segments and what's true about those points right there. So we can go ahead and play a little bit. We can change it to a vertical line and see if our conjectures still hold true, and then with a slanted line as well. And once they've made their guesses, we can now go to a different template. And again, I'm going to reflect this about the horizontal line. And you can see now it's giving me distances, telling me that SA and SA prime is 4, TB and TB prime is 7, and UC and UC prime are the same values each. But that's only on one example. We can now do a whole bunch of examples just by playing and moving this around. And that's going to be true no matter if we're going to be doing a horizontal line, a vertical line, or even a slanted line. Although with the slanted line, you can see the numbers are not so nice because it's it's going along diagonals, not along the grid. Now I know some of you are saying, "Now where's the grid and where's all that?" Well, we've got that too. We've got plenty of things to show you. All right, so let's go ahead and go to a template that does have grid and coordinates, number 5. And somebody's saying, "Oh, finally." Okay, and I'm going to pull this so that it's all above the x-axis for now. And I'm going to reflect about the line y equals 0. I couldn't use that before because I didn't have a reference for that, so I'll reflect. And you can see there's definitely some kind of pattern going on here with the values of the corresponding vertices. And you can go ahead and see if that holds true all the time. And so students will make a conjecture about that based on many examples, not just one or two. And instead of teachers telling students this is how you do it, they can discover that. So now I'm going to go ahead and change this to a vertical line, the line x equals 0. And now we have a different correspondence here, a different relationship. And then we can also go with the line y equals x. And that's an interesting one as well. You can see that xy goes to yx no matter what. By the way, look how quickly we discovered these, not just told students, but they discovered them for themselves. All right, let's look at using other equations besides the three that we use. So I'm going to change the template to be, excuse me, slopes with equation. And now what I can do is actually click on the equation and decide, do I want an equation of the form y equals mx plus b, x equals a constant, or y equals a constant. Let's go with y equals a constant, and maybe with y is equal to, let's say, 2. And let's put this all above that line there. And go ahead and reflect about the line y equals 2. And you can see there is some kind of pattern going on here. And even here there's a pattern. Okay, you can talk about what that pattern is. These are different than what we normally do, but we're able to do it because of the technology. But my favorite line to reflect about is the line y equals the opposite of x. So I'll just put negative 1x there. And let me grab this here. And you'll notice, look what xy maps to. xy seems to map to opposite y, opposite x. And I know somebody say, well, this isn't one of the things that is tested on our state test or whatever, but it's a great way to look at looking for patterns and discovery, and it's easy to do. Now, there are many other things you can do here, and we're not going to have time to do them all, but I thought it'd be kind of cool to look at the movable line reflection method under the tools. And in this case, what we're going to do is we're going to have the line move instead of the triangle, although the triangle still can move. Okay, so I'm going to reflect this about the line y equals x. Not a surprise. But instead of moving the figure, let's move the line. I can grab either P or K and move the line, and you can see how it behaves there. Other things that we're not going to have time to look at is we can talk about how corresponding angles and sides are congruent, perimeters and areas are the same. We already investigated something about the slope, or about the coordinates. The slopes of corresponding sides, there's a very interesting relationship there. You have the chance to turn on all the options and so on. You can zoom in, you can zoom out. If you need to have a question about shortcuts, what do all the shortcuts mean? It's all here for you. Please go to this bit.ly link and click on the link to get a 90-day free trial so that you can do not only this activity, but all the activities at this website and over 1,000 pre-created activities at mathinspire.com. Please contact me with questions. Enjoy.